Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I'll be working through the triangle exercise from the Exorcism.io Ruby track. So in this exercise, we are called to implement a class that can determine whether or not a triangle is equilateral, isosceles, or scalene. And if you need a refresher on that, like I did when I first looked at this, an equilateral triangle is one that has all three sides the same length. An isosceles triangle has at least two sides the same length, at least for the purposes of this exercise. An equilateral triangle is also an isosceles triangle because it has at least two sides the same length. And then a scalene triangle has no sides of the same length. All sides are different lengths. And then for a shape to be a triangle at all sides have to be of length greater than 0. There cannot be a single side that has a length of 0. The sum of the sides, or the greater or equal to or less than 0, I should say. The sum of the lengths of any two sides must be greater than or equal to the length of the third side. And that is due to a principle called triangle inequality, which you can read about here. All right, so let's see. So I don't know if we'll do this dig deeper case. I guess I will. The case where the sum of the lengths of two sides equals that of the third is known as a degenerate triangle. It has 0 area and looks like a single line. Feel free to add your own code and test to check for degenerate triangles. Okay, so maybe we'll implement that. We'll see how this goes. Let me go ahead. Let me copy this. I'll start, let me copy this first. My rake file, remove the empty Ruby file, and I'll start a new tmux session. Let me open up the test file and see what we're looking at. So we have a class called triangle inside of a triangle.rb file. You initialize it with an array of 3 sides. And then you can ask certain questions of it. There are these predicate methods here: equilateral, isosceles, scalene. Okay, so cool. Let me go ahead and open up my testing pane. This is enough to get started. All right, so let me go ahead and create that file. Swap those panes real quick, and now it'll complain because I haven't initialized the triangle class yet. So I'll do that. And then I think the next thing is going to want me to do is to define initialize to take an argument. Yeah, that's exactly right. So I'm going to go ahead and create an adder reader for my sides array, and then define initialize to take sides, and then set it to the instance variable, or save it to the instance variable here. Next, it'll complain because I have not defined an instance method equilateral. So in this first one is going to fail because it's expecting true, and we're not returning true. So I'm just going to go ahead and return true and move on to the next one here. So this one is expected to be false, so it's going to fail because we're returning true explicitly. So I've got to actually check this. And so what I want to know is whether or not all these sides are equal. And so I think probably the simplest way to do that, I've got my sides in an array, is if I unique my array, I'll get a new array containing only the unique elements. And if it is equilateral, meaning all 3 sides are the same length. So over there, I've got 2, 2, 2 for my first example. Then the length of this unique array will be equal to 1. All right, cool. And I think this will get me through, let's see, test triangle is not equilateral if no sides are equal. Yep, that's correct. 0 sides are... Test all 0 sides are illegal. Okay, I'm not checking for this. So this will fail because they're equal, but I also want to know that that no side is equal to 0. So I think what I want to do here is I'm going to go ahead and create a valid. I want to know that it's a valid triangle, and I'll create this method as a placeholder. I'm gonna make it private. And for the first check, I want to know if it has any zeros. It can't have any zeros. And so I will take my sides array and sort it and make sure that the first element is greater than or equal to 0. No, sorry, greater than. It must be greater than 0. Okay, cool. So let's continue. Equilateral triangle sides may be floats. I don't see why that wouldn't work here. Triangle is isosceles if the last two sides are equal. Okay, this will fail because I have not defined an isosceles method yet. So I need to do that. All right, so let's get on with that. No, that comes I comes after E. Isosceles. And of course it'll fail because it's expecting true. So I'm going to go ahead and I'm just going to cut to the chase and implement this. I want to know that it's valid and that sides unique length is less than 3. It can be 1 or it can be 2. If there are exactly 2 sides of the same length, then sides unique length will be 2, right? Because it'll be the 2 that are equal will collapse into 1, and then there will be a third one. But if all 3 sides are equal, if it's equilateral, that is also an isosceles triangle as far as we are concerned. So let's see, test the triangle is isosceles if the first 2 sides are equal. Okay. Test that it's isosceles if the first and last sides are equal. Yep, I don't care about order. The way that I'm checking this. Equilateral are also isosceles, yes. And test if so it's not isosceles if no sides are equal. Okay. Sides that violate triangle inequality are not isosceles. Okay, we're not testing for triangle inequality. And so remember, with triangle inequality, what that states is that the sum of any 2 sides must be equal to or greater than the length of the third side. So we need to add that test here. And I think the easiest way to test it, because I don't want to test every combination, every permutation. So I think if we check the 2 shortest sides, the sum of the 2 shortest sides must be equal to or greater than the length of the third side. So what I want to do is I want to sort this here as well. Sort. And then check the first 2. I want to check the sum. And I want to know if the sum is greater than or equal to sides sort last. And then I'll need to check that in addition to the check for the first 0. Okay, so I'm going to go ahead and pull out this bit of duplication here where I'm sorting every time on every check. I'm just going to sort on the way in. And then, I mean, that should just work as is. Let me remove these sorts. Down here. All right. All right, cool. Let's keep going. Test that sides violate triangle inequality are not isosceles. Okay. Triangle inequality violation. What do we got here? Let's see. Isosceles triangle sides may be floats. Yep. And now we have our first scaling test, which will fail because I haven't implemented scaling. So this is going to test that no sides are equal, that all sides are unique. So let me go ahead and define scaling. And I'm just going to go ahead and implement this here. What I want to know is that sides unique length is exactly equal to 3. All right, let's keep going. Test the triangle is not scaling if all sides are equal. Yeah. It's not scaling if 2 sides are equal. Sides that violate triangle inequality are not scaling, even if they're all different. All right, and then they may be floats. All right, cool. All the tests are passing, so let me do a little bit of refactoring here. Actually, no, before I do that, I forgot. They asked us to do this dig deeper here. They want us to check, add some tests and a check for a degenerate triangle. So that is if the sum of the lengths of 2 sides equals that of the third. That's a degenerate triangle. So here, let me open my test again. And I'm going to add this. Test degenerate triangle. So let's see. Test sum of 2 sides is degenerate. Okay, so we want a triangle. I'm going to create a triangle here. Triangle new. So let's see. 1, 2, and 3. Right, so that meets the conditions because 1 plus 2 is equal to 3. So this is a triangle that will have an area of 0. Triangle degenerate. Expected true for triangle 1, 2, 3 is degenerate. Of course, this will fail because there is no degenerate A method. Change. Read your test, people, because if I had not read it, I would have been confused in a minute. Undefined method degenerate. Let me define this. Degenerate, it's valid, and sides, let's see. So what I want to do is I'm going to check. So I'm going to do that similarly to my check for triangle inequality. I'm going to check that the sum of 0 to 1 of those 2 elements is equal to sides dot last. So it's a valid triangle. It does meet the triangle inequality test, but because it's exactly equal to sides dot last, it is it's a degenerate triangle. So let's do a counter example. Let's see. Test non-degenerate is false. I'm not really sure what to name this. Let's just do create a new triangle, new 1, 3, 4. No, that is 1, 3, 3. So assert triangle degenerate. Expected false. Triangle 1, 3, 3, 3 is not degenerate. And What have I done? Degenerates. Oh, huh. Interesting. Underscore. All right. Expected false. It is degenerate. Triangle degenerate. 1, 3, and 3. So, wait a second. It is degenerate. 1, 3, and 3. What's going on here? Why is this degenerate? Let's see. Acquire pry and then binding.pry. Let's see what's going on here. Let me see which one we've got here. I've got my sides 1, 2, and 3. We know this one is degenerate, so let's continue. All right, sides 1, 3, and 3. It's valid. That should be true. So what is sides 0 to 1 dot sum? It's 4. What is sides dot last? It is 3. So sides 0 to 1 sum equal to sides dot last. That should be false. All right, so let me just play line 10. Did I do that right? Play dash L10 is false. Oh, refute. I need to refute it. All right, everybody. Let's get rid of that. So I'm a little distracted by my kids. One of my kids is taking a bath across the hall from where I'm sitting right now, and is being a little loud over there. And I'm just thinking how like that's gonna be. I've got to have this weird noise in the back of this video. So I'm I was a little distracted. Anyway, okay, so that's it. I'm not going to bother to add these other tests to make sure that these other cases are handled, because I mean I know they're handled here because of valid. So let me go ahead and close the test, and let's refactor this a little bit. So I want to name these bits of logic here. This one I'm going to call. I'm going to just name this. So what would this be? What I'm testing here for degenerate is 0 area is what I'm really testing. 0 area. That it has as an area of 0. 0 area. And the way that we test that is we compare the length of these two sides with that side. So equilateral, all sides equal. All sides equal. Def, all sides equal. Okay, for isosceles, we would just want to test that 2 sides are equal. So you see what I'm doing here is I'm naming the bits of logic according to the language that I use to describe it. And this last bit of logic I want to name here, sides unique. And there's not a lot of harm in leaving this here, but it just makes it more readable. It makes it easier to maintain, because when I come back in, I don't have to untangle multiple things at a time when I'm looking at this. So here, scaling. Is it valid? Well, it's valid. Oh, it is. Is it scaling? It's scaling if it's valid and no sides are equal. Or you could call it all sides unique. No sides equal. Okay. Let's see. One more thing here is I want to name this bit here, because so now the valid method is doing multiple things. It's checking all the different validations, but it's also defining what they are. So this one I want to call triangle inequality met triangle inequality met A. And then there's one more bit of logic there that is the other thing here. Sides dot first is greater than 0. So I want to know contains no side 0, no side 0, no side 0, def no side 0. That should actually, if I'm doing this in alphabetical order, should go here. All right, so what does it mean for it to be valid? Triangle inequality is met and no side is 0. And actually, I'm going to add something else that I don't have a test for here, because it's also if it's also only a valid triangle if sides length is equal to 3. And I'm just going to leave this right here because to me this is kind of self-evident. It would be pointless to give this a name. You know, what would you call it? 3-sided? All right. So this, I think this is it. Yep. I like it. I'm going to go ahead and submit it. All right, cool. Thanks for watching, and I'll see you in the next video.